Hi, I'm going to talk about how to remove a negative frequency from your phonon dispersion. This is phonon dispersion for my structure, and I know that should be positive, not negative. But let's look at here. You can see there are three acoustic mode. Here is gamma, here is 000. And there are three acoustic mode. That makes sense, but there is something extra here, which shows that my structure is not the most stable structure, so I should move atoms in order to get lower energy, and then I can remove this. So the first step in order to remove negative frequency is to get eigenvector. But how to gain eigenvector? Let's remove this. I'm going to put this side, which I use in order to get the eigenvector. If I'm using with VASP and DFTB plus, but if you are using Quantum Espresso or another software, you can convert your structure to Pascal file, and follow this in order to get this eigenvector. So the first step is to open your structure in the VESTA. For example, this is my structure, and save it as a Pascal. Pascal with the Pascal.vesta. So it's just put a name same Pascal and save it. And the second step, you need this file extract vector phonopy.py and running this command. When you run this command, save your Pascal file with this VESTA in the VESTA application, and this file is from your PHONOPY. I think if you have already worked with PHONOPY, you know this. And using this file, and you can download this file from up here, which is here. So copy this command. We have all of these three, this one, and this one in my directory. So I'm going to run it. Okay, so I cannot run it from here, but I'm going to work in the different environment and using this. So in this directory, for my directory called Virtues, there is it's a created VESTA files, and then that you can find here is the VESTA file. I'm going to open it in my computer, which is already here. Here is the VESTA file. So here is the call point and wave number, and let's look at this. For example, I need to see what's happening Let's draw phonon dispersion again. It a little takes time, so here is it. So we can find at 0, here is 0, 0 is the, you can see in at 0 I have some negative frequency, okay, and the biggest one is this. But if I open the 0, 0, 0, you can see there are some negative. The biggest one is related to this. But for example, let's open the first one. If I open the first one and we can edit it, edit vector, move, you can change 1 to 5 for example to see vector better. Okay, this is the first one, but let's go to the second one. Second one, again, edit vector, and here 5 is okay. You can see the second one, you know, acoustic mode, all of the atoms moves together. This is makes sense, all of the arrows is in the right direction. But the first one, you can see, oh, that's for example, this is in this direction, this atom is in this direction, so this is not acoustic mode. We should remove this. So I'm going to we should move atom according to this eigenvector. For example, this one in this direction a little, this one, this atom in a little in this direction, and optimize our structure again. You can see, for example, your structure, the energy of your structure will decrease. So then you can get phonon dispersion again, and you can remove your phonon dispersion. But I'm going to talk about how to move atoms in the second video. So there is nothing wrong with this. If I open the other negative one, edit vector, and here is 5, you can see all of them are in the same direction. This is acoustic mode, so this makes sense. But the problem is this. So we should move atom according to these eigenvectors. For example, this to this direction, this to this direction, and to get to optimize it again to see if the energy change or not. For my structure, here is it. For my structure, I gain eigenvector and I moved the atom according to the this one. And here is the result. Here is the result. Let's see what's happening here. Yes, you can see there are 3 acoustic mode, still negative, but there is no extra thing here. So there is no extra. Let's see again. There is 3 acoustic mode here, and there is no extra thing here, so that is good. Now the problem is superset size. In this here is my structure is 211. The superset is 211. That is so small. I'm going to expand the superset, for example 222, and stuff like that, to remove this small negative one. So if you have a big negative one and you are sure that your structure has positive frequency and is stable, so you should gain eigenvector. According to the eigenvector, you should move your atoms, so you will get one structure with lower energy, so you can get phonon dispersion again, and you can remove this. Thank you.